Welcome to the Module 3 of our video tutorial series on Programming DSP using Code Composure Studio version 4. In this module, we will see how to import an existing project, load and execute the project, how to observe the outputs, how to use the graphical windows and memory windows. We will also cover how to export the data in .dat files. So let us start. Click on the Code Composure Studio. It will open a blank workspace for us. Click on Projects, Import Existing CCS Project. It will throw a pop-up for import. Now click on Browse and select the file from where you want to import a project. So in the DSP content folder, we have a supporting file folder. And within the supporting file folder, we have sample projects. And within the sample projects, we select myproject.pgt. Click on OK. Ensure that we have a check mark in copy projects into the workspace. This is done so that we create a local copy of the project and do not modify the main project. Click on Finish. To the left hand side, we observe that the project has been included in this workspace. Double click on this project to observe all the files that are associated with this project. Towards the bottom side, we have a file samplecode.c. Double click on the file to open it. This program has been written so that the LEDs can act as a 4-bit countdown timer. We first build this code. This can be done by using Ctrl B command, or we can click on project and build project. So this will build a project and check if there are any errors in syntax. If we do not get any errors, we can proceed to debug. Debug will essentially load the program on the DSP and make it ready to execute. We can debug this using debug button shown here, or alternatively we can go to targets and debug active project. So now our code has been loaded on the DSP. To execute the code, we can click on the run button shown here, or we can go to targets and then click on run. Before we run this program, we would like to observe the state of LEDs. As seen, no LEDs are glowing as of now. So now we run the code, and what we will be able to see on the board is the LEDs have started countdown timing. If we halt this program, we will observe that the LED counting has stopped. So this demonstrates how to build and debug a project. To demonstrate other facilities of Code Composure Studio, we need to have a code which defines an array. For that, we will first terminate and remove this connection. To replace this file, we can either edit its contents, or we can add one more C file to the project and delete the existing file or exclude it from the build options. Right click to delete the file or to exclude the file from build. Right now I will exclude the file. Let us see if we have another C file. In module 3, we have a sign.c file. We copy this file to our project. Right click and paste. So we have sign.c file included in our project. We double click on this file to see its contents. In the file, the first section declares the external function prototypes. The second section has been left blank because we are not using any functions which are declared and defined within this program. And the third section declares all the global variables that are being used in this program. In the main section of the code, first we initialize the DSP. Then In order to implement a harmonic oscillator which will generate a sine and cosine waves, we initialize the state of the harmonic oscillator and initialize the counter. The next is the most important and crucial part, that's the harmonic oscillator implementation. We update the counter and reinitialize the buffers. We need to reinitialize the buffers because we have limited size of RAM on chip. We will first verify whether there is no syntax error in this code. So we have to build the code. Click on project and build project. If there are any errors or warnings, they will be displayed on the console. In case of errors, we will have errors in the problem screen. Right now we have no problems and we can go ahead with the debugging. Click on the debug button to program. This will launch a debug session. Now we run the program and halt. To observe the waveforms that we have generated, we need to use a graph plotting tool. We will use the built-in graph plotting tool of Code Composure Studio. For that, we need to know the name of the variable, the data type and its size. Double click on your file to expand it. We have x and y as the variables where we have stored our signal. The data type is floating point and the size is 100. We go to tools, click on graphs and single time. This will allow us to plot a single waveform. Here we need to modify 4 fields. The first is acquisition buffer size. This is the size of the buffer, 99 in our case. We are also going to change the display data size to 99. The next thing is the data type of the variable. Since we have used a floating point variable, we are going to select 32-bit floating point. And we also have to mention the starting address of the variable. So we write address of x and then we click on OK. So on the bottom side we can observe that in a window named single time and some counter number, we have plotted a sine wave. Suppose we want to observe both the variables x and y. In that case, we can go to tools, click on graph and dual time. Here we will enter once again the acquisition buffer size as 99, display data size as 99, data type as 32-bit floating point, starting address of A is address of x and starting address of B will be address of y. Click on OK. We'll bring this window down over here. So single click on it, stretch it and pull it down. So we'll have dual time A2 and dual time B2. What we can observe is the plots on both the graphs are 90-degree phase shifted. This is due to the implementation of harmonic oscillator, which generates a sinusoidal and a cosine signal. We can also export these waveforms into a .dat or a data file. For that, we need to observe the memory window first to check out the values in the buffers. We can have a memory window existing in the Code Composure Studio, or if it is not visible, we can click on Views and then click on Memory. So this will highlight the memory window. Here we enter the name of the buffer and whether it is in the program data or IO. Since X lies in the data compartment, we are going to select data and type address of X and hit enter. The next important thing is to select the data type. So we click over here and go to 32-bit floating point values. These are the values through which this graph has been plotted. To export this, we click this tiny button which says save. We can set our own location, say desktop, and name of the file, say sign dot dat file. Click on save. Next, since I have file which has the same name as this file, I will replace it and say yes. Okay. The floating point is the data type of this variable. Starting address is x, memory page is data, and length is 99. We click on finish. Having done this, when we see a desktop, we will have a sign.dat file ready with us. Let's try to plot another variable. This time we'll first observe y, 32-bit floating point value, and we have the values. We click on save. This time I will write cosine dot dat file and save. We click on next. Verify the format is float. Starting address is now y. The memory page is data and the length is 99. And then click on finish. This will create a data file named cosine. Now Code Composure Studio will create a data file with its own header. To change the header, we double click on the file, select the first line and delete it. Save this file, close it. Similarly for the sine wave, we delete the header, save the file and close it. Now to plot these waveforms in any external plotting tool such as Qt Grace, we open our software. We click on data, import ASCII. We navigate to a directory where we have our files. So we can see sine and cosine. Double click on the files and you will have your plot ready. I'll click on cosine as well and close. Okay. So using external plotting tools, we can verify that the two signals that are generated are phase shifted by 90 degrees. Using other features, we can add axis labels and modify this image as well. However, right now I will close this window. Last but not the least, before closing any project, we need to first terminate and remove the connection of the DSP and then close the workspace. By default, whenever we close a workspace, Code Composure Studio will save our project, and when we open it the next time, it will open the same project with the same file, so that we do not have to perform the import operation every time we open the Code Composure Studio. Thank you.